All right, so we did that first one together. So we saw that 16 to the 1/2 is 4. If we try this for the next two, we get 25 to the 1/2 is 5. 49, whoops, has the exponent key in extra time. 49 to the 1/2 is 7. So what do you notice here? What seems to be happening with the numbers? What's the connection? Akira? Yeah, it's really just the same thing as taking the square root of 16, which is 4. The square root of 25 is 5. And the square root of 49 is 7. So on the poster sheet, if we look at the middle poster here that has squares, this is going to be helpful in thinking about square roots. So square root is just going backwards. It's starting with the squared number result and turning it back into, okay, what was the original number that needed to be squared to produce that result? All right, so I'm just going to make a few notes here off to the side. So in this first little section here, let's just make a note that in general, anything raised up to the power of 1/2 is really just doing the square root of that number. All right, and if we were to add in a little bit more right here, so a specific example of this, if we have 16 raised up to the 1/2, it really just means that we're doing the square root of 16. So it makes sense why we get down to the answer of 4. Now to go the other direction then, it's 4 squared, that turns it back into 16. All right, we're going to jump over here to take a look at the next set of problems. These were all raised up to the 1/3. So we had 27 to the 1/3, which was 3. We had 8 to the 1/3, that equaled 2. And then we had 1,000 to the 1/3. That ended up equaling 10. So what do you think is happening here when we raise it up to the 1/3? What's going on? It's just doing a cubed root instead of a square root. And so if we take a look at the posters, and we look at the poster of all the cubed numbers, we can see, well, 3 cubed is 27, 2 cubed is 8, 10 cubed is 1,000. So when we're raising it up to the 1/3, it's really asking what number cubed would have equaled that result. So I'm going to make a note off to the side of this section that generally anything raised up to the 1/3 is equal to a cubed root. And there's a slightly different way that we're going to write that. So it's going to involve a symbol that kind of looks like the square root symbol, except we need a way to designate that it's a cubed root and not a square root. And so we're going to put a little 3 here in the corner, kind of like the example of the symbol that we had up at the top of our paper. That's telling us, and we'll put the little A on the inside, that this is a cubed root. So the way that would look, if we write out this first one, the 27 to the 1/3, we would write this as the cubed root of 27, and that's how we get the answer of 3. And going the other direction, it's 3 cubed that is equal to 27. Now, let's go back to the square root here for just a moment. I'm going to label this square root. Notice how we don't have a little number in that symbol, and really it's an invisible 2 that's here. So actually whatever is the denominator of the fractional exponent, that's going to be the little number that goes here in this position. Square roots are just so common that we don't typically write the 2 in that position. So if you don't see a number here at all, so going back to this, if it just looks like that, we're assuming that it's a 2 that's there. here at the raising up to the 1/4. So we should have gotten that 81 to the 1/4 is 3, 16 to the 1/4 is 2. Well, following the pattern of what we've been doing, if we take a look at the posters, and if you look at the 4th poster, notice how 3 to the 4th is equal to 81. So the 4th root of 81 is 3. If you look at 2 to the 4th, that's equal to 16. So the 4th root of 16 is 2. So in general here, anything raised up to the 1/4 is equal to the 4th root of that number. So for the 81 to the 1/4, we can rewrite it with the symbol looking like this. We just have a little 4 in front of that root symbol. And the connection with the numbers going the other direction is that 3 to the 4th is equal to 81. All right, and then finally the last two. These are being raised up to the 1/5. So that means that these are 5th roots. And so when we look here at our posters, I didn't make this list very long, but we have a couple of 5ths on here. So notice how 2 to the 5th is 32. So the 5th root of 32 should equal 2. And 3 to the 5th is 243. So we do the 5th root of 243, and it's equal to 3. So in general, anything raised up to the 1/5 is going to be a 5th root of that number. All right, now we're going to put in 2 more labels here. I want to just give a little bit of vocabulary to the work that we've been looking at here. Instead of calling these exponents that are fractions, we're going to rename them as rational exponents. So if we think about this word rational, the first 5 letters spell the word ratio, and a ratio is just a fraction. So when we're talking about rational exponents, we see that up here in our first learning target for today. Understand the meaning of a rational exponent. That is just an exponent that's a fraction. The other thing I want you to know is about the symbol that we've been using here. So the symbol that we used for a square root, a cubed root, and so on, we have a special name for that symbol as well. So the symbol, I put it up here at the top of our activity sheet. This is called a radical. We'll just write this out as a radical symbol. So a radical could be a square root. It could be a cubed root. It could be a 5th root. Anytime we use that symbol that kind of looks like the square root symbol to begin with, it's called a radical. All right, so using what we have looked at now so far, we should be able to answer some of these without using a calculator. So if we take a look at the questions down here below, we know that anything raised up to the 1/2 is really just asking us to do the square root of that number. So we can do an in-between step here of putting it into the radical form, and we can think, okay, the square root of 64, what number squared is 64? And that would be 8. And even though it says to do this without a calculator, you could answer these by using the poster chart in front of you. So you could look at the column of squares and figure out what number squared is 64. That's what we could think about here on the next one. So anything to the 1/3 is wanting us to do the cubed root of that number. So when we take a look here at our list of cubes, we want to see what value has an answer of 125. In this case, it's 5 cubed. So that end result would be 5. For the next one over here, we're doing the 4th root of 256. So looking at our posters, we want to look at the column of 4ths, and we see the one that has an answer of 256 is when it's 4 to the 4th. That final answer is 4. All right, now we're going to make a connection with what we have talked about so far to solving some new types of equations. So down here at the bottom it says that Brody also has some math homework to finish before tomorrow. So we're going to see if we can help him figure out how to solve these problems. So in the first one here, we see the radical sign present. It's in the form of a square root symbol. What is something that we could do right at the very start that would undo or get rid of the square root sign? What can we do here, Yash? Well, whatever we do to one side, we want to make sure we do that same thing to the other side. If we add a square root on this side and not the other side, it's technically not keeping our equation balanced. So we want to always think about doing the same thing to both. What's a way, though, that we can undo if a number is getting square rooted? What would be the opposite or the reverse of taking a square root? Ed? So if we raise both sides up to a power, we would actually want to raise both sides up to the power of 2. So rather than raising it up to the 1/2, that would just cause another square root symbol to go on top of it, and then it'll get even more complex. But to undo it, we want to think about squaring both sides. So if you think about a number, like let's say we have the number 25, and if we square root it, we get 5. And then if we take that answer and then square it, it's going to turn back into the same number that we started with. This is kind of like the function compositions that we talked about last week. So if we want to undo a square root, we just need to square it. And so on this left-hand side, the square root symbol is going to go away. So that square root symbol gets canceled out when we square. And so the only thing we're left with is whatever was underneath. In this case, that's 4x plus 1. Because it's an equation, we do the same thing on the other side, and so we get that 3 squared is 9. Now it turns into a nice simple equation that we'll just continue solving for x. And we get a final answer here of 2. All right, now let's take a look here at the second problem. So this one does look a little bit different at the start because we don't see a square root symbol, but we do have a rational exponent. We see that this whole quantity is being raised up to the power of 1/2. Well, what we saw a little earlier is that raising something to the 1/2 is the same thing as taking the square root of it. And so we can immediately turn it into radical form as our first step so that we can see that familiar looking square root sign. And now that we've turned it into the form of the first equation, we can just continue solving it the exact same way. So next step will be squaring both sides. That square is going to undo the square root symbol, leaving us with just 3x minus 23. And we do have 5 squared on the other side. That turns into 25. And that leaves us, again, with another pretty simple equation to solve for x. All right, so because both of these equations involve the square root symbol, which we learned is called a radical symbol, what we call these types of equations is we call them radical equations. Yes, active. Yeah, so because anything raised up to the power of 1/2 really means that we're taking the square root of it. So it's just a different way of saying the same thing. So in showing you both forms of the equation. The method for solving it is exactly the same. And what I'm wanting to show you is that sometimes you might see the square root symbol. Other times you might see it being raised up to the 1/2. It means the same thing. So the steps for solving will be exactly the same. All right. Let's go ahead and turn over to the back. So we're going to finish up by summarizing what we saw so far today on the front page. So our first learning target here was to understand the meaning of rational exponents. The second one was to evaluate rational exponents without a calculator. All right, and we saw that a rational exponent is really just an exponent that is in the form of a fraction. Now, all of our rational exponents in the activity had a numerator of 1. It doesn't have to be 1. You could actually have a numerator of anything. And so to make this a little bit more general, let's say that some number, we'll call it a, raised up to a rational exponent could look something like this. So we'll have m represent the numerator part of the little fraction. We'll have n represent the denominator part of the little fraction. So when we put this into radical form, we're still going to have the radical looking symbol, which looks like a square root symbol. Whatever the denominator is of your fraction is still going to be the little number that goes on the inside. If it's 2, you don't have to write the 2, but if it's anything other than 2, we want to indicate what that number is so we know what type of root it is. Now the a number is still going to go underneath the radical sign, and the numerator part, which we are now calling m, is actually just a regular exponent that's going to stay attached to whatever a is. So, for example, here's what this would look like for one of the problems that we did on the front page. Let's revisit 25 raised up to the 1/2. Well, this is really the square root of 25 to the first power. So notice how the little denominator tells us what type of root we have. The numerator is attached to the 25 on the inside. Now, it's not normal. We don't have to write the little 2 in there. Normally that 2 is invisible. We also don't have to write 25 raised up to the first power. Normally, we would just make that invisible because 25 to the first power is just still equal to 25. But I wanted to show you that technically the position of the 1 and the 2 still go in the positions that I told you just a few minutes ago. Here's one that looks a little bit different. So let's say you have something like 16 raised up to the 3/4. Well, this is going to be the 4th root of 16 to the 3rd. So that one looks a little different. We have to have the 4 here to tell us it's a 4th root, and we have to have the little 3 in there, really just because it's not one. All right, our last learning target here was to apply techniques to solve radical equations. And there's 3 steps here that I want you to write down for this process. Step number 1 is to isolate the radical part. So that means we need to get the radical part by itself. If we take a look at this check for understanding problem, you would have to add 1 to both sides first before you could square both sides. All right, step 2 is we are going to square both sides, or you could cube both sides, or you could raise to the 4th. You just want to undo whatever type of root you have. So if you have a cubed root on both sides, you want to raise both sides to the third power. If you have a fourth root on both sides, you want to raise both sides to the fourth power, and so on. All right. So down here in part B, something to notice right away is that although we don't see the radical sign, we have a rational exponent. So we have a little piece of the equation that's x raised up to the 1/3. So something that we could actually do at the very start is rewrite that as the cubed root of x. Technically, it's the cubed root of x to the first power, but x to the first power is just equal to x. Okay, so before we do anything on the both sides, we need to get the radical part all by itself. And so we need to get rid of that -7. So that would be a place to start, just like we would with solving other equations. We'll go ahead and add 7. And then we also want to get rid of that 5 that's being multiplied out in front. So we would do that by dividing both sides by 5. All right, so now we can finally think about raising both sides up to a power. So notice how on the left-hand side here we have a cubed root. We know that it's a cubed root because we have a little 3 here. That came from the original denominator. It was raised to the 1/3, so it's not a square root. This is a cubed root. And so if we want to undo a cubed root, we're not going to square both sides. We need to cube both sides. So that is how we are going to get the cubed root part canceled. So that's going to leave us with just regular x on the left. And then on the other side, 3 cubed is really 3 times 3 times 3. So that's going to give us a final answer of 27.